Hi, this is Shane with Ozone Water Systems. Today's video, I'm going to demonstrate how to connect into our Ethernet IP bridge. It uses an IDEC bridge, and this will show you how to connect into it with your Studio 5000 with the CompactLogix or ControlLogix PLCs. We use this bridge to tie the Modbus signals from our Ozone generators through the bridge, and then to communicate with your control system with your Allen Bradley PLCs. First, let me just show you. This one's I've already got it, the module created, and I've got it set up, and I can see the values. I can communicate with our Ozone generator through the bridge. I just want to demonstrate that real quick. So I've got the Ethernet module. I've just named it FC6A. That is the first part of the part number for the bridge that I'm using. You can name this whatever you want. It's just to identify the I/O points and the connection as going to the bridge. So that's up to you, and you can give it a description here. It shows you the assembly instance identification number and the number of data registers that are being sent back and forth to the bridge. You also give it the IP address for the bridge, and then once you've created this in your controller tags, it'll automatically create these three address files. The indicator with the I is all your inputs. These are information coming from the Ethernet IP bridge, and of course from the Ozone generator. The O addresses are the outputs from the Allen Bradley PLC back to the Ozone generator to give it run commands, send the watchdog signal, and that. So if we open up these tags, you can see the individual data points and the values that are contained in those. We will provide you with this spreadsheet that shows you what each data number indicates, what its possible values are, and the scaling if it needs to be scaled. There are some digital bits that are buried within a data register. For example, we can watch the watchdog pulse coming from the generator. This is on data number 22, bit number 9. So if we come over here, we go to data number 22, and then go to number 9, that bit would be pulsing on and off. Let's get online with the PLC so we can watch these data registers communicate. So now you can see that I've connected into the bridge, and you can see this bit pulsing on and off. That's our watchdog pulse. And this will show you all the different alarm tags that are available. All of these are contained within there, and there's this particular data file contains 2 generators. So let's take a look at data 0, and we can see what control mode the generator is in. So if we go to data 0, we can see it's in value of 3. If we come back to the spreadsheet, we can see a value of 3 indicates that it's turned off. That's how the data works. This is you can also go down to the outputs. We scroll down here on the spreadsheet. These are the outputs. So the output control signals, you send a signal of 0 to 1,000, and that equates at the generator to 0 to 100%. You can also, if the generator is set in the proper mode, you can send the control mode to it and change modes from purge to off, remote, local, and so forth. We also have some digital bits. You do need to send a watchdog pulse back to it. I'll show you logic for that in the PLC real quick. That's a simple way to do that. And then you have a remote run bit for each generator. And then you can also, there's an ambient reset. If ambient goes off, it is latching, and an operator needs to reset that. So you do have those bits available as well. I won't get into a lot of detail on this. If you have this in your system, we will discuss it with you and make sure that everything is clear on how the different addresses are used. Real quick on the logic for that, the easiest way that I've found to produce the watchdog signal is to just watch it. This is monitoring the watchdog signal from generator number 1, and I just make a ladder rung that takes that bit that we're watching, and then I just send it straight back to the generator so that it's getting the pulse, the watchdog pulse it's expecting. I've just got one here for each generator. I'm not monitoring generator number 2 at this time. I'm just generator 1 for an example. Now that I've showed you how you communicate with it and how you access the data, let me quickly show you how to create the connection for it. I'll just leave this connection there. We'll go offline. You do need to be offline to create the new connection. So let's say this was not here. You right click on your Ethernet and you click New Module. And we're just going to create a generic Ethernet module. So you can just type Ethernet module in the, depending on what other devices you've got in your list. In my list, the only one that pops up is the generic Ethernet module. This is the one you want. Select the generic Ethernet module, click Create, and then we're just going to input all the data that we want. Give it your name. We'll just call this FC6A Bridge, Ozone Water Systems Generators. Call it, just whatever description you want. The data type is int. Give it an IP address. And this is whatever the IP address is of the port that you're using. Our Ethernet bridge has 2 ports. Port 1 is generally used for local communications on the skid. Port number 2 is what you'll be tying into with your Ethernet bridge connection to the generator. And then you put in your instance assembly numbers. This is 100 with 25 registers. These numbers may change if you have a custom setup. The outputs are 101 with 5 data points, and then the configuration, just put a 1 with a 0, and that's all you need. When you click OK, it's going to create, and it's not going to let me put that in there as a duplicate IP address, so I'll just change it to, let's just call it 11. Once you create that, if we go back to our controller tags, we'll see that it's now created another set of connections for that bridge. So you can see that it just automatically populates these, and it will give it the right amount of data registers that we've set in there. So we have those 25 data registers. So now those are in there. Now this one's not operational because it's just a made-up one, but you see how easy it is to make that connection. Now in the second part of this video, we're going to get into showing you how to alter the IP address over a web browser for the Ethernet IP bridge. So let's go into that. This video guide is to show you how to set up the Ethernet IP bridge. It's this IDEC PLC unit, it's an FC6A-D16. It's a PLC, but it's acting as a Modbus to Ethernet IP bridge. Port 2 is dedicated for your customer use, and that port 2 is routed straight down to this bulkhead fitting in the bottom of the cabinet. That's where you'll plug in for your Ethernet IP connection. Goes to the bottom of the cabinet. The port 1 network is always going to be at a fixed IP address. The 2 ozone generators are fixed IP addresses, and those communicate with the bridge via Modbus through port 1 and through this Ethernet switch. So we don't want to alter the IP address for that, or we'll lose communication to the generators. The port 2 can be adjusted for your internal IP address requirement, and I'm going to demonstrate how to set that up. This spreadsheet has the data information to set up your Ethernet IP configuration. It has all the data registered information and descriptions, scaling. All that information is in the spreadsheet for your inputs and outputs to the system. Also included in this spreadsheet, on this other tab at the bottom, is the port 2 IP configuration. Default port 2 configuration is 192.168.1.6. That IP address for port 2 can be configured to whatever it is you need. Let me show you how to access the system to enter your custom IP address. So I've got an Ethernet cable connected to my laptop. First thing you want to do is set your laptop computer to an IP address as seen on step 1 of 192.168.1.20. Subnet is 255.255.255.0. We're using 1.3, 1.4, 1.5, and 1.6 for port 2, which can be changed. Take that Ethernet cable, and you want to connect that into the Ethernet switch, which ties you into port 1 of the Modbus to Ethernet IP bridge. That one is always going to have an IP address of 192.168.1.5, so you can always connect to that to do any configuration needs. The other port, like I said, goes straight down to the bulkhead at the bottom for your connection. I'm going to show you how to adjust the IP address for that so you can customize it for your network. We've done step 2 of the instructions. Now what we want to do is open up a web browser. I'm using Google Chrome for this. And in your browser, you want to enter an IP address of port 1. That's 192.168.1.5. You'll get a password login prompt. The default username is administrator, lowercase. The password is just the word password. Once you've accessed the interface for the bridge, the first page you're on is the PLC status page, and you can see various information if it's in running mode or not. If you scroll down, you can see the network settings for port 1. These should not be changed. And you also see the network settings for port 2. These are the ones that are adjustable. We have a default IP address in there of 192.168.1.6 and the subnet mask. These two can be changed, as well as the gateway to allow you to access it from your own network. To make adjustments to that, there are 2 ways to do it. The batch monitor is preferred, but let me quickly show you the custom monitor just so you've seen it. On the spreadsheet over here is all the data registers that you can adjust to customize your IP address and subnet mask and gateway. You can manually enter these values in here, D8631. As you can see, that's the first octet of the IP address. If I go to D8632, there's 168. So you can see you could manually plug these in, and you could edit these right here. Somewhat easier way to do that is to go to the batch monitor. It's my preferred method. Enter a data register in this field of 8630, and then you can see you have access to all the data registers that you need right here without typing them in. So 8630 plus 1 is our 8631. I'll just change the last digit on this. So if I want to change that to a value of, say, 10, I just type 10 in this dialog, hit enter. I change our IP address to 1.10. Now, it's not yet written to the data registers, so we have to enter the bit to write those registers. Once you've entered all your IP address information and subnet, now we're going to go back to the custom monitor, and we're going to enter the right bit in here to the device address. That is M8333, and enter. And just so you can watch it when it writes, I'm going to put the 3rd octet of the IP address. These are the read-only values down here on the spreadsheet. So if I look at D8660, D8660, I can see that currently has a value of 6. Now when I set that to write the new value that I've just changed to 10, I'm going to click on this value on M8333, enter a value of 1, and hit enter. And it will now update the IP address. So now I've got an updated IP address of 10, and the new IP address is now written. If I go back to the PLC status screen, I can then scroll down to the settings, or the settings for network settings on the port 2, and you can see that I now have an IP address of 1.10. Now it means it is, once it's visible in this section here, you know that it's been written permanently to the Modbus bridge. It is important that you do not change any other data registers while you're in here other than the IP addresses listed on this list. These addresses are the only ones you should modify within the Modbus bridge. Editing anything else could cause undesired operation. Any questions, please contact our office. Telephone number is 480-421-2400 in the USA. Email address to reach us, you can contact us through info@ozonewatersystems.com, or you can try to get reached directly to myself. My name is Shane. I am one of the electrical engineers and control engineers on the project. Thank you.